All right, we're going to continue on our unit of radicals and rational exponents. And now we're going to get into solving equations. With everything that we currently have learned in this unit, we're going to apply those things to two different concepts. The first concept is solving equations. The second concept will be graphing. But for right now, let's just work on solving equations. All right. So we have these examples of equations that involve radicals and rational exponents, and we just have to figure out how to find the value for x that would make these statements true. Okay, so we're going to do one thing at a time. We'll attack one example at a time, but just keep in mind the whole thing with solving equations has to do with undoing operations. Okay, so that's how we're going to isolate variables, is by undoing operations, and then we're going to hit a couple of snags and we're going to cross that bridge when we get there. All right, so in the first equation, we see something rather peculiar. For those of you that like to copy things down before you work on stuff, I have to give you this first note. You must be super careful on reading the symbols. Okay, so be careful with the symbols. And I'll tell you what I mean by that. If you look at this equation, notice how the radical symbol covers 4x plus 1. It covers 4x plus 1. It doesn't only cover the 4x, and it doesn't cover the minus 5. It's covering only 4x plus 1. And that's going to make a big deal, because what is getting the square root? 4x plus 1, not just 4x. And not 4x plus 1 minus 5, just 4x plus 1. So you must be careful with reading the symbols, especially those of us that like to copy things down. Okay, so basically it's how do you read this? The square root of 4x plus 1 minus 5 equals 0. All right, so notice the gap, the pause, and it's all about reading symbols carefully. All right, so how do we approach this? The same as what we did in Common Assessment 2. Oh, the dreaded Common Assessment 2, that dreaded second test. And what we're going to do is isolate the grouping symbol first. Okay, so we're going to isolate the grouping symbol first. And that's a good way to approach it. Even though we have it something equal to 0, can we use a zero product property with this? No. So we're going to isolate that grouping symbol first. So we're going to do some basic stuff like add 5 to both sides. Okay, so all we've done is added 5 to both sides, right? So now that we have isolated our grouping symbol, what do we do now? We need access to that x, right? We got to get to that x, but that x is stuck inside this radical. Darn it. And so what we have to do is undo that radical. All right, so we have to undo the radical. Now, this particular radical is the square root, right? And how do we undo a square root? We undo a square root by raising something to the second power. Okay, so we undo the square root by raising something to the second power. So if we're going to undo this radical, what we have to do is the inverse operation, right? Undoing the operation. Inverse operation, raising both sides to the second power. So we have the left-hand side being raised to the second power, and we have the right-hand side being raised to the second power. So we have to also, again, be careful with the symbols. Now that we're dealing with sides, we're going to have to group those sides, and so we're going to use grouping symbols. Okay, be super careful. Now, what's going to happen here? I'm going to come back to this example momentarily. Since we're undoing the radical, right? Here we've undone the radical by taking the inverse operation. Guess what we can do? We could totally lose the radical. And if we lose the radical, we're just going to be left with what was inside it, 4x plus 1. That's why we raised it to the second power to begin with. We've undone the radical. And I'll show this example again later, and you'll see why. And now we have the other side, 25 to the second, or 5 to the second power, of course, is 25. All right, so now we have this, and then it's basic, now it's back to pre-algebra, algebra 1. So we can do that. So now we're just going to undo some stuff. We can subtract 1 on both sides, and then divide both sides by 4, and then we have our value for the variable that would make the original equation true. Okay, now how do we know that that original equation is true? We test our answers because we might be running into our good old extraneous solutions at some point. So it's really, really important to be super duper careful and check our answers. Okay, so just make sure that we are good to go. All right, so we'd have this, and all right, so the square root of 4 times 6 is 24, and 24 plus 1 is 25, and then of course the square root of 25 is 5. 5 minus 5 is 0. Okay, this checks. All right, so we're good. We're good here. Next, most definitely x is equal to 6. Okay, so we're good with that. All right, so it's really important to check your answers on this stuff because we might be running into extraneous solutions. But the key note here is right in this section. We gotta pay attention to that, and I'm going to show that again in the next example. Speaking of the next example, bloop, here we go. Now we have problem number 2. So what in the world is going on with that crazy, that's a rational exponent. What? And I'm going to show you what to do when we get there. But everything else, of course, it's the same as before. There's no need to freak out and give up. Again, like I say in class, Survival 101, keep busy doing something. Even though it might not be right, at least you're doing something. So we're going to make the same note as we did in the first example. We have to isolate the grouping symbol. All right, so isolate the grouping symbol. And since we have a grouping symbol here, but there's the 2 being multiplied by it, how in the world would we isolate it? Simply divide both sides by 2. So how do we isolate the grouping symbol? We divide both sides by 2. Now we get to go into some crazy talk. How in the world are we going to undo that exponent? Right? So that's what we know we have to do. We have to undo to the 3rd power. So how in the world do we undo to the 3rd power? What is it that will undo something raised to the 2/3 power? And now this is where I'm going to go back to that other example. Do you remember how we undo a radical? Okay, the way we undo a radical is raise it to the 2nd power, and the way we undo the 2nd power is you take the square root, right? So let's apply what we know about that. We know that to undo a radical, we're going to raise something to the 2nd power, and vice versa. Let's use rational exponents real quick. Can we express the 2nd power in rational exponents? Isn't the 2nd power the same, the square root, isn't the square root the same thing as to the 1/2 power? And hopefully you're saying, why? Why, yes, Mr. Katz, it is. Okay, so that means if taking the square root of something, undoing that is raised to the 2nd power, that means having something raised to the 1/2 power, the way we undo that is raise it to the 2nd power. Now, what's the relationship between 1/2 and 2? So what's the relationship of 1/2 and 2? Why, they are also inverses of one another. What? That's right. If you take 1/2 and you flip it, you get 2. And if you take 2 and you flip it, you get 1/2. Right, don't forget the hidden 1. Okay, so isn't that neat? So how did we undo this radical? Why? Even though it looked like we took the radical and raised it to the 2nd power, what we actually did is raised it to the inverse power. So what did we actually do here? We actually raised it to the inverse power. Amazing. Right? So you might have been wondering as we were going over this one example before, like why are we doing something we've done before? Because we're going to show you a different way to do it. We actually did is raised it to the inverse power, right? Isn't that a neat note? So how do we undo something raised to the 2/3? We're going to raise it to the inverse power. Raise it to the 3/2. Okay, so that's how we undo rational exponents. Raise it to the inverse power, exclamation point. Isn't that cool? Okay, so that's the big note here. I mean, seriously, I can be done. I can just drop the mic and walk off stage, and we'd all be knowledgeable. So I'm going to use that note. I have x plus 3 to the 2/3 equaling 4, but what are we going to do? We're going to raise this entire side to the inverse power, and we're going to raise this entire side to the inverse power. How cool is that? Now, why in the world would we do that? Hopefully you can see what's happening right here. If we've undone to the 2/3, well, clearly we'll just have x plus 3. But how do we know for certain that's what we have? Laws of exponents. A power to a power means we multiply the exponents. 6 over 6 is 1. Anything to the first power is just itself, and that's why that works. Holy cow, that's pretty awesome. But now what we got to do is figure out the right-hand side. Now we have 4 to the 3/2 power. What are we going to do? Remember, there are two ways we can look at it. We can look at it as the square root of 4 cubed, or we can look at it as the square root of 4 cubed. Cubed, not second, cubed. All right, so it doesn't matter which way you look at it. We're going to agree that it's 8. Okay, so it doesn't matter which way you look at it. It's going to be 8. All right, 4 to the 3rd power is 64. Square root of 64 is 8. Or 2 to the 3rd power is 8. Doesn't matter. It's 8. This whole side is 8. And then basic pre-algebra, some really elementary school work. X is equal to 5. And is that true? Okay, so again, we might be coming across extraneous solutions again, so let's be careful. So let's test our answer just in case. So is 2 times 5 plus 3 to the 2/3 power, is that going to be equal to 8? Well, let's do some work. All right, 5 plus 3 is 8. Now we're going to figure what is 8 to the 2/3 power. 8 to the 2/3 power is the cube root of 8, which is 2. 2 squared is 4. 4 times 2 is 8. Check. Okay, so 2 times 4 is 8. We're good. X does equal 5. We're good. Nothing to worry about for extraneous solution. So we're all set to go. All right, and that's how we work with number 2. The key note, boy, was right here. Bam! That is such a cool note, and that's going to help us every time. Okay. With that, we can just go crazy now. Okay, so now what are we going to do? Let's take a look at number 3, because number 4 gets nuts. So let's take a look at number 3. We have this next example. What are we going to do? We can do all sorts of stuff. Notice what's happening. We have a variable on both sides of the equal sign. And that, of course, means there might be extraneous solutions. And you know what we're going to do? We're going to do the same thing we've done before, which is isolate the grouping symbol. Because this one is going to get fun. So we're going to isolate the grouping symbol. And again, for those of you copying, make sure you're paying attention to what has a square root and what does not. All right. So now we have to isolate the grouping symbol. And then what do? The same thing we've done before. We're going to undo the grouping symbol. Okay, so we're going to undo that square root, or raise both sides to the inverse power. So what that means is we're going to take the left-hand side and raise it to the second power. And now you're going to see why I've been saying side so crazily in all the other examples. So we're going to take the right-hand side and raise it to the second power. And right now, there should be something that clicked in your brain that looked at that and said, uh-oh, FOIL, or multiplying polynomials, or perfect square trinomials, or what have you. Okay, so hopefully something clicked in your brain right there. And yeah, that's what it's going to take. So we're going to undo the grouping symbol by raising both sides to the second power. So far, so good, I hope. If not, hit pause and go back and try it again. Anywho, undoing the square root is going to leave us with 5x minus 1. On this side, what's going to happen when we multiply x times 3 by itself? X squared minus 6x plus 9. And if you don't believe me, do it the hard way. Work this out by multiplying polynomials, and I'll meet you and hit pause and meet you in a couple seconds. And clearly it's going to be x squared minus 6x plus 9. Now, how in the world do we solve this? We solve this the same way we used to solve quadratics, right? You remember how we solve quadratics? No, I don't. All right, so here's how we solve quadratics. Set things equal to 0, right? And then use the zero product property or quadratic formula. Okay, so you can sing it. X equals opposite b plus or minus square root b squared minus 4ac all over 2a. Okay, so once we have quadratics, we're going to solve quadratics. Either set it equal to 0, zero product property by factoring, or use the quadratic formula. All right, that's what I'm going to do. So if we're going to set this equal to 0, I want to keep this positive. That means I'm going to subtract these two things, okay? So I'm going to have 0 equals. Okay, that means I'm undoing the left-hand side. I'm subtracting 5x. Watch how fast I've done this. I'm going to subtract 5x on both sides. Did you see that? Did you see that? I subtracted 5x on both sides. And then I'm going to add 1 on both sides. Did you see that? I added 1 on both sides. Great. Now you can use the variety of methods. Hopefully you can tell that this can be factored. Okay, and if you know that this can be factored, go ahead and factor it. And if you don't know this can be factored, go ahead and quadratic formula it. We're going to agree with our variables anyway. So no matter what, if you're at home, hit pause, factor it. If you're in my class right now, I'm hitting pause, factor it. So either way, pause, factor it. We will agree on this. Okay, so no matter what, we're going to get these two things. Right? Now we can use the zero product property. And we can tell this. Okay, so again, if you're at home, hit pause. If you're in my class, I hit pause. Well, hopefully by now I've hit unpause. Then you might be giggling. All right, so we have our two solutions. Darn it, we have two solutions. What do we do now? Now we test. Are one of these or both of these extraneous? We don't know. So the first thing we're going to do is test out 10. All right, so remember the original equation. The square root of 5x minus 1 plus 3 is equal to x. Okay, now is that going to work? So we have the square root of 50 minus 1, which is 49. Is 49 plus 3 equal to 10? Square root of 49 plus 3 equals 10? I hope so, because 7 plus 3 equals 10. We definitely know 10 works. How about 1? Okay, so let's test that out. So we have the square root of 5 times 1 minus 1 plus 3. Does that equal 1? Let's find out. Okay, so we have 5 times 1 is 5. 5 minus 1 is 4. So the square root of 4 plus 3, I don't think is 1. Unless, if we're dealing with principal roots, right? So we have the square root of 4 is 2. 2 plus 3 is not 1. Therefore, 1 is extraneous. Dun, dun, dun. Nope. Extraneous. Okay, so our solution of x equals 1 actually does not work. So the only solution that we have is x equals 10. Now, remember we talked about principal roots before, and that's where this comes in. So we have all these fun things out there where people can prove 1 plus 1 equals 1 and all that stuff, and it deals with positives and negatives and square roots. Anywho, that's how we work on that third example. Now for the last one. This gets fun. All right. So, what would happen in number 4, if we were to square both sides. If we square both sides, nothing's going to work. So let's just do this step by step. There are some fun things that we can do. And I'm going to stick with the same first note. And the first note, isolate the grouping symbol first. And I know you're looking at me and going, Cats, come on, man. Are you blind? There's 2 grouping symbols, buddy. I know. But what I mean by undo the group or isolate the grouping symbol first is let's get this big grouping symbol by itself. That's one way we can do it. So 5x plus 4 is equal to the square root of x plus 4. All I did is added the square root of x on both sides. Okay. Now, some stuff is going to get crazy. Check this out. Now we're going to undo this big grouping symbol. Okay, so undo the big grouping symbol. And of course we do that by raising both sides. There we go again. By raising both sides to the second power. Is that going to solve our problems? Maybe, maybe not. We're going to find out. On the left-hand side, 5x plus 4. On the right-hand side, I don't know. How in the world? What are we going to do? Let's multiply that out. How do we multiply the square root of x plus 4 times itself? Well, FOIL. Square root of x times square root of x is x plus 4 times the square root of x plus 4 times the square root of x plus 16, which is x plus 8 times the square root of x plus 16. Well, that's weird. Now we have this. Okay, so let me hit pause, make sure we're good here. I may have done this too quickly. I'm going to talk slowly now or ask you to pause the video. Right? Make sure you understood what just happened. Did foiling and combined like terms and all that stuff, and this is what we get. So now you're thinking, now you can hit unpause. Then again, if it was paused, you didn't hear me say unpause it. So now go ahead and rewind. Now you know when I'm asking you to unpause, and there we just hit some kind of time-space problem. So now that we've unpaused it, we're looking at what do we have. What do? Let's do the same thing over again. Isolate the grouping symbol again. What? Cats, are you kidding me? No, this is awesome. We're going to isolate the grouping symbol again. Here's our grouping symbol. Let's isolate it again. How are we going to do that? We're going to subtract x on both sides. So notice what's about to happen. I'm going to subtract x on both sides. Did you see I did that? Did you see I did that? I subtracted x on both sides. You saw what I did? Saw what I did? Good. I'm also going to subtract 16 on both sides. So what is that going to look like? You see what I did there? I subtracted 16 on both sides. See what I did? See what I did? And what is that going to leave me? It's going to leave me with this. 8 times the square root of x. Not quite isolated yet. So let's divide both sides by 8. I'm going to divide both sides by 8. So I have this. I almost did this quickly, but I thought better of it. And when I divide both sides by 8, what will I get? If you notice, all these things are divisible by 4, right? If you notice that, they're all divisible by 4. So we have x minus 3 over 2 is equal to the square root of x. And now what? Now what? Well, guess what we do? We do the same thing again. We're going to undo the grouping symbol with division. Division, right? So, I'm not division. We're going to undo the grouping symbol with raising to the second power. What's wrong with me? So now we're going to raise both sides to the second power, and this is going to get crazy. So we have on the left-hand side, x minus 3 over 2 times x minus 3 over 2. On the right-hand side, good old x. And now on the left-hand side, how in the world are we going to do this? We're going to use a couple of properties of fractions and do this. Right? Right? Hopefully you're with me. And then we're going to do this. And then we're going to have the 1/4 out to the side. And then we're going to have x squared minus 6x plus 9. Right? Equaling x. What do we do with quadratics? We set them equal to 0. Okay? So we're going to set this equal to 0 by subtracting x on both sides. I'm going to do something so crazy, and I hope you're paying attention because it's going to be awesome. How in the world can we work with this? Is this going to be x squared minus 7x plus 9? No, because this is what we're actually looking at. We're looking at x squared divided by 4 minus 6x divided by 4 plus 9 divided by 4 minus x. So I need to call this 4x divided by 4. And then I can call that minus 10x plus 9, right? And then some things can get can be worked with. You've got to be careful here. This is some really good fraction work from elementary school that we have to be ready for. So I'd have the 1/4 out here, and then x squared minus 10x plus 9 equaling 0. Okay, that is some intense things. Now, what we also could have done to avoid that confusion is we could have also, at this stage, we could have also multiplied by 4 on both sides, right? Coulda, shoulda, woulda. And that would have eliminated that fraction, right? We could clear fractions at any time. Okay? So there are some things that we could do that would make life easy. Just don't give up. Whatever you do, don't look at the fraction and say, oh, I don't get it and I'm done. Don't do that. Don't give up. There are things that we can do to make life easier. Now that we have this, we can multiply both sides by 4. We can just factor this and use the zero product property. Either way, let's go ahead and factor what we have. Okay, so we're going to factor what we have. That'll be x minus 9 times x minus 1 equaling 0, thus leaving us with x equaling 9 and x equaling 1. And now we have to test those answers. Okay, so now that we have that, we're going to test those answers back into our original. Okay, so I'm going to test on the other side of my work. So clearly I'm out of space on my paper. Just please, whatever you are doing, don't give up. Okay, so we have x equaling 9. Is that the case? Well, we have the square root of 5 times x plus 4 minus the square root of x. And does that equal 4? Okay, so let's do some numbers. 5 times 9 is 45 plus 4 is 49. So does the square root of 49 minus the square root of 9, does that equal 4? Right? That's the question. Does 7 minus 3 equal 4? Well, yes, it does. We know x equals 9. All right, so we're good with that. Now we're going to test the same thing with 1. Okay, so we have this 5 times 1 plus 4 minus the square root of 1. Does that equal 4? All right, so we're going to test that out. So let's go. 5 times 1 is 5, and 5 plus 4 is 9. So does the square root of 9 minus the square root of 1 equal 4? Square root of 9 is 3. Does 3 minus 1 equal 4? No, it does not. That means this is extraneous. Our only solution is x equals 9. We did all that work just to have one answer. Man, oh, shevits. So this is where solving equations is so much fun. So hopefully you enjoyed that. This is good times. Do your homework.